So the first instrument was flew in 1997 on the tropical rain measuring mission. But in 1999, it was launched on the Earth Observation System Terra, while in 2002, CERES instruments were launched on the AQUA-MODIS, according to NASA. CERES M5 is currently flying on the Suomi North Polar Program satellite mission, and then CERES M6 is flying on the Joint Polar Solar System 1 spacecraft. The radiation budget instrument, which is RBI, is scheduled to fly on the JPS-2, while the JPS, which is part of an American program with other countries like Japan, Europe, and so on. So the NOAA and the NASA, they collaborate together to launch. So this is the multi-angle imaging spectro-radiometer from NASA instrument, was mounted on the 18th December 1999. And this is the typical data from the satellite, which is optical aerosol depth. This was collected 2000, and then this is the parameters on the data. So this is the typical for the whole world. The highest value and then the lowest value.
This one of the things relates to the transmissivity factor, remember? The transmissivity.
Yeah. Radiative transfer that.
Optical depth, the one I mentioned, there was a line that decreased. That's the optical depth there.
Now, maybe some of you must have heard of MODIS. This is the Moderate Resolution Imaging Spectrometer from NASA, also attached to AQUA, and usually is referred to AQUA-MODIS. This is the one that is taking the ocean color, and then you can do a lot of analysis from the temperature and wavelength, sea surface temperature, wave height of the ocean, and many other things. So the MODIS satellite was designed to provide a very large-scale measurement of the global dynamics together with the changes in the Earth cloud cover, radiation budget, and then processes occurring both on land and ocean and the lower atmosphere. So MODIS uses the marine optical buoy by measuring the light at the sea surface, in order to define the location of a long period of time, as well as the ocean color observations intended for various calibrations. A lot of parameters that we can get from it. So the visible infrared imaging radiometer, which is VIIRS, is an instrument that was used to replace the MODIS on board the Suomi MPP. MPP means North Polar Program. That was launched 2011. So this MODIS has been replaced by this in 2011. And also in the impending the Joint Polar Satellite System satellites. That is the one that will be launched in 2019, which I have shown previously. Now this is typical example from the AQUA-MODIS satellite data. This is the infrared. This is 2018, August 21. This is the time 11:15, and so on. So this was the typical data obtained on this date by the satellite. Now, the measurement of pollution in the atmosphere. This is the satellite that is measuring all forms of pollutions in the atmosphere. A typical example is this carbon monoxide pollution from the global data of MOPITT. MOPITT is the name of the satellite. So you can see the concentration of carbon monoxide. Places like my country here, Africa, South America, Brazil, and so on, the Caribbean, and other notable places in the North America, and then the northern part of Europe, which is close to the polar, and Japan and Korea. But Malaysia is very free. Also, we have some places like, I think, Afghanistan and some other countries, so with very high carbon monoxide pollution. Now, the MPP, just to give you some information on the MPP. The MPP is to provide continuations of the Earth observation system record of climate quality observations after the Earth observation system Terra, which is the first one that was launched, followed by the AQUA and the AURA. It will extend key Earth system records and or climate data record of equal or better quality and uncertainty in comparison to those of the Terra, AQUA, and the AURA sensors. Now, to provide risk reduction for the JPPS instrument, the algorithms used, the ground data processing, the archive and prior to launch of the first JPPS spacecraft. But note that there are now plans to use the North Polar Program data operationally. The GOES system, operated by the National Oceanic and Atmospheric Administration, National Environmental Satellite, and Information Service Division, which supports weather forecasting, tracking of severe storm, meteorological research data. The next generation radar, which is NEXRAD, is a network of 158 high-resolution Doppler weather radar operated by the National Weather Service or agency of the NOAA. So the Global Ozone Monitoring Experiment, GOME, is an instrument aboard the ERS, which is European Remote Sensing Satellite, that was launched by the European Space Agency. So some specification of the sensors, just for your information. For high spatial resolution, when you want to use high resolution data, this is the one to look for. The ICONOS launched in 1999, and then these are the parameters of the data. Then the QuickBook that was launched in 2001. So these are the two sensors that give a very high spatial resolution of remote sensing data. When you talk of high spectral resolution, then they have the AVIRS and then the Hyperion that was launched in 2000. These are the two satellite data that will give us a very high spectral resolution. This one will give a very high spatial resolution. And then for high radiometric resolution, the 8 bits. So when you are trying to download the data, these are the parameters you need to look for you to be able to get the one that is suited for your need. The high temporal resolution is the GOES and the NEXRAD. Then the globe coverage high repeatability to improve temporal resolution. These are the satellite that has the data, the MODIS and so on. Then when you talk of real-time or near real-time availability, the MODIS, NESTRAS, and then MPOEWS. So, in continuation, cost, free or affordable. Most of the images collected for research purposes, they are free, but the high resolution one are not. You have to subscribe or make certain payment. The integrated remote sensing or the GIS, which is the package that is mostly used for the analysis of this data. So these are the software in case you need to use maybe in the nearest future. You go MV, ERDAS. This is what the one I use is PCI Geomatics. The ARMAPA, Intergraph, IDRIS, and the C5 tree decision. I've tried to learn how to use the most recent. The most recent one is the C5 tree decision, which is not so common. The links to this software is here. In case you are interested, you can always go there to download for student use or for personal use. So, for the recap, remote sensing started actually in 1909. So, but that time it was aerial photograph, which was the original form then. But later it was developed. After the 1915, the aerial photograph was widely used in the WWI, while the photogrammetric engineering, which is the official monthly publication of the American Society of Photogrammetry, was first published in 1934. The color infrared photograph began in 1931, then was widely used in agriculture and forestry. But between 1930 and 1940, radar was developed. During the World War II, WW2, which is World War II, non-visible spectrum, the infrared and the radar were used as tools in remote sensing. After the first man-made satellite, the first man-made satellite is called Sputnik 1, which was launched on the 4th of October 1957 by the Soviet Union. Remote sensing moved to the outer space, ignited the space race with the Cold War. The United States Explorer 6 transmitted the first space photograph of the Earth in August 1959. Then, the first system meteorological satellite observation came with the launch of the US CERES 1 in 1960. The Landsat, for those of you that maybe you have used remote sensing data before, you have Landsat 1, Landsat 2, and so on, Landsat 7. Landsat 1, originally called the Earth Resources Technology Satellite, or ERTS, it was the first satellite to collect data on the Earth's natural resources, and it was launched on the 23rd of July 1972. The hyperspectral remote sensing emerged in the 80s and was widely used for mineral exploration, oil and gas exploration, and then all other Earth resources explorations. Since then, a large number and advanced types of remote sensing systems have been developed. Now, some of the terms I did not define. It was like CAMS. If you see that, it means Continuous Atmosphere Monitoring Service. That is mostly of European satellite. The C3S is the Continuous Climate Change Service. The European Center for Medium Range Weather Forecast, which is ECMWF. And then the European Organization for the Exploitation of Meteorological Satellites, UMESA. Ocean and Sea Ice Satellite Application, that is OCSAT. And then the Interface Data Processing Segment. These are just to introduce you into remote sensing. The details of analysis depends on what you want to do in the future. Now, you can now go into details of theoretical and the practical aspects. So, thank you very much for coming again today. And I wish you take profession or specialist in remote sensing. It's very interesting, but forget about the mathematical aspect of it. For now, thank you.